CAST CONNEX, we are structural engineers who specialize in looking at conventional methods of building steel structures and how we can improve on those that construction utilizing the technology of cast steel manufacturing. So the difference with castings is we're able to make a mold, and then we pour molten steel into that mold to make the shape that we need for the connection. What we're able to do with castings is kind of take a second look at complex connection where there's a lot of members framed in one area, or if it's heavily loaded. You might end up, if you were to try and use the existing steel shapes, you might end up with a very, very complex and messy thing that would be difficult to fabricate and also difficult to design. And so what we can do with a casting is we can go back to square one, sort of. So we just use engineering fundamentals to say, where do I need material? Let's put it there. And then we're able to build a mold that reflects that sort of optimized shape. And so a lot of the design, as I said, is driven by the force flow. And also what we're keeping in mind while we're doing this is how is it actually going to be fit into the building? So how is the steel fabricator going to work with this part? What is it connecting to? What's the best way to make that connection? What are the requirements in the code for inspection or weld requirements, things like that? And how can we also take that into consideration and optimize the likelihood of getting a quality weld, minimize the inspection that might be needed by perhaps being able to use bolts rather than welds in a typical connection. In addition to the standardized products, we also provide what we would call maybe design build or design supply services for custom applications. So we'll have someone come to us and they'll say, we have a 350-foot diameter dome with 20-inch outer diameter tubes, something like that. And these connections are going to require like 500,000 bolts or something like that if we fabricate them, and it requires like so many miles of welding, like that would circle the world a few times. And you simplify it, and we can, because rather than these complex connections with a lot of that need a lot of capacity through like welding and bolting or whatnot, we can just put material where we need it in the casting. Because we're able to make these sort of sculptural elements, it turns out that castings are really nice complements in architecturally exposed structural steel applications. Per the Code of Standard Practice, castings are not architecturally exposed structural steel, but what you can say is they are aesthetically pleasing structural elements that can be connected to architecturally exposed structural steel. So, as I said, very much complements AESS applications. So with the castings, what we do is all of those parts that might have been welded in the shop or welded in the field or bolted or whatever, depending on the application, we do that all in prefabrication, let's say. And then it's 100% inspected. So we know that that thing is perfect when it goes to either the fabricator. We take that part that would be difficult, complex to fabricate, and would likely be prone to potentially human error. And we cast it. And so it arrives to the fabricator, and that headache is gone for them. All they have to do is, connect it to the rest of the structural steel. One of the connectors we make is called a high strength connector. One of the things we try to do at CAST CONNEX with the high strength connector in particular is, rather than doing like the couple pages of calculations for this special concentric brace frame, you look in a chart that we have and you figure out like, okay, this is the size of brace, this is the capacity, here's the bolt layout that I need, and you're done. So we've done all those checks already, and it's also been tested in a laboratory to show that it works the way that it's supposed to. Another connection we make is, we call this the high integrity block. So it's for applications where you have usually like super tall buildings with very, very heavily loaded members. So often what they'll do is take like 2-inch or 4-inch thick plates and then stack them together to make, say, a 3-foot, 2-foot, whatever the cross section is that's needed. And then they get welded on the edges to each other. There's some inherent problems with that. It's not actually, in your design class, you assume that steel is isotropic, but in fact, it's not, because of the way that it's manufactured. We developed the capability of manufacturing a block of steel, so rather than a bunch of plates welded together, a block that actually is isotropic. So it's manufactured in a different way rather than being rolled, it's cast. And then it's forged. So forging is, you know, that classic image of like the guy takes a horseshoe out of a fire and beats it on an anvil. That's forging it and improves its performance for certain applications. Do that, but on a very large scale. So anyways, other than having this complex connection and worrying about having different steel strengths in different directions and how do I get it so that I'm not loading that plate in tension so it might tear, we just give you a big block of steel that's isotropic and you can do whatever you want to it. So we call that one the get out of jail free card for designers, and it's weldable, all of that. So it greatly simplifies things. All steel is recycled, same thing with castings. And I would say the benefit that's there, well, I know, yeah, for sure, the benefit that's there is we're putting material where we need it for the flow of forces. So we're able to make lighter connections, less material, requires less energy to make them, to transport them. And then we're also minimizing the weight again. Say we could have fewer bolts or less length of weld. So welding is also another, you know, energy intensive effort. On sort of a next level thing is the seismic damper that I spoke of. That's actually developed so that we can design a building so that it will survive an earthquake and actually be usable. So if you don't, you know, the code, the minimum that the code requires is that everyone can get out of the building, but to properly design something such that it will be habitable afterwards is a huge savings. From the design side, we're simplifying design, right? We're also allowing architects to express their creativity. So they can basically sculpt steel. On the construction side, as I said, we're taking responsibility for that connection. We are communicating with the contractor, the fabricator, the erector, to provide them with something that is going to be the easiest thing for them to work with and save them time in the shop and in the field. And then ultimately, if the thing is lower cost, that means that the owner benefits. Which if you have a private owner, it's like, well, they're a millionaire, who cares, right? But if it's a public project like Salesforce Transit Center, taxpayer money goes to that. So in that example, there were cast steel nodes on that building, but they had not been properly designed. And so we were brought in to design them, and we cut over $4 million off the budget. Everyone benefits both on the design construction side and also on the user side from having more economical, safer, and hopefully more beautiful built environment.